recording, I might not be doing as much of the pausing and answering question a little bit. So if you have any question, make sure you kind of note down what you want to ask and then ask. Okay. So now the thing is that the reason why we need to do data processing in biology simply because one thing compared to biology versus chemistry and physics is we deal with variation. We deal with vast amount of variation. So for example, if you look at this class, this is a grade 12 class, so I'm assuming a lot of you are, what, 17, 18? 17, 18? Or 17, 16, 17, okay? 16, 17, a lot of you guys are 16, 17, okay? You guys are living in a relatively small, like, sample size area. Yes, it's Scarborough, but then the thing is that it's not like, we're not even talking about GTA, and I'm assuming diet-wise, it's not going to be ridiculously, vastly different, okay? So in this case, but if you do that, if you look around, even just things like height, just things like height, there's a wide variety. Because biology, we also deal with, we deal with the environmental factor, as well as we deal with the genetic factor, which, so in this case, when we calculate average and things, it's going to be different. For us, we want to know, are those differences significant, or are they just random by chance? Is this normal differences? Okay, so in order to do that, we need to do things like standard deviation and whatnot. So that's why I'm going to teach you guys how to do that. Now, first off, 2 links. Some of you look like you have accessed it earlier when I was walking around. Some of you don't. As I said, I want you to use Microsoft Excel. You guys as TDSP students can access a free version of Excel using your TDSP account. So if you click on this link here, it'll tell you that, oh yeah, you just signing up with your TDSP will have a free subscription to Microsoft 365. So the instructions are here. Here's a link. You click on that, and then you should be able to go. So I click on that. And because I've done this already, as you can see, I would get to a page that looks like this. Okay? So that's what this one link does. Now, that's not what I want. Okay, so delete this. So in this case here, I have some made up data, which is similar to what you guys had to do. Okay, so if you look at your handout here, okay, so if you look at your handout here, you have a data table that is given to you. On this column, which is the stage of germinations, how long have those seeds been germinating? And here, for each germinating stage, you have 5 trials, okay? So they germinate the seed for half a day, and then they crush up those seeds to do the experiment with it. And here they have 6 trials, and each trial they have to record the time of volume of oxygen gas being recorded, okay, after 30 seconds. So I still want you to do this yourself. So in this case, I kind of made up some data, okay? It's not necessarily going to be the same or whatnot, but here it is. And I'm just going to zoom in a little bit so you can see it a little bit easier. Now, means means averages. So one nice thing about Excel is that you can actually get it to calculate things for you. So means is called averages. So if you click, you select the cell, press equal sign, and then I press average. It actually has a built-in function or built-in formula for calculating averages. So you put that in and you put a bracket. Now, in this case, it will say, oh, what do you want to calculate the average of? You select these 5 cells here, you press enter. It will automatically calculate the averages for you. You don't need to plus this 7.5 plus 8 plus, and then divide it by 5. It will automatically do the average for you, okay? Now, one other nice thing about Excel or spreadsheet is this. Since we're going to be calculating average for each of these rows anyways, I can click on this square, drag down, it will do it all for you, okay? Some of you know this, some of you, this is first time seeing it, okay? Any questions so far? I know I earlier asked you. Okay, now one thing here, if you look at all these trials, so the first row, these are kind of relatively, it is spread out, but it's not that spread out. Here, this is a lot tighter. The samples are all like close to 10.1. Here, this one, you have 16, you have 17, you have 16.5, you have 17.8, and then you somehow have a 25. Now, later on in university, you will have to if you notice that, hey, I have this 5 trial, one of this is ridiculously different from the rest. In university, they would actually want you to do a stat test and see how different is it? Is it significantly different compared to the other set? For now, if you visually look at it and you do notice, this is really different. What I will want you to do in the future is exclude that, but you'll write an explanation later on, okay? So how do you calculate that? So I did the averages already, if you look. Averages B5 to F5, meaning this here. Now I don't want to include the F5, I just want to go from B5 all the way to E5, 17.8. So what I do is click on this here. And I change it to E5 instead. And voila, it calculated for me, changed it a little bit. I think earlier it was 18 something, now it's 16.8, which fits closer to these ones. Okay, and then the rest, it looks like that. It does look like the averages. So the second part, standard deviation. Again, you guys have not learned it before, but as I said, you don't need to know how to do it mathematically by hand or by a calculator. I just need you to know how to do it on a spreadsheet. So again, Excel has a function for that. You put equal sign, and then just STDEDV. Now you notice there are a couple of different versions of standard deviation. You will look, and you will probably use this one, STDEV.S. It means estimate standard variation based on the sample, ignores logical value and text in the sample. So you choose this one instead. Now, typically, you can just type that in, and I don't know why it doesn't show up, but here it goes. Point S, and then you put a bracket. Again, I want the Excel to calculate the standard deviation of these 5 numbers, these 5 cells, B3 to F3. So I press that, calculate the standard deviation for me. And I'll address. And since I will want Excel to do the same thing for all this row down here, I will just select this dot, pull down, And again, it does the standard deviation calculation for me. Okay? Are we good? Now, a couple of things. First off, we know that for the 3 days germination, this set, we're excluding F3, the 25 mils number. So here, for the standard deviation here for this cell, we're also going to change it from B5 to E5, simply because, as I said, we're excluding this. It's way too different compared to the rest. So the standard deviation get recalculated. Now, if you look here, look at the standard deviation row. Standard deviation tells you how different, how widespread are each of your data from the rest of that sample. So if you look here, if you look at this column, this row here, day 2, you have 10, you have 10.1, 10.2, 10.1, 10.1. Everything, it's very close to 10.1. So which means the standard deviation will be very small because the data didn't really spread that much. Versus if you look at this column here, this row here, day 4, you have 25, 26.5, 27, 20. It's a pretty widespread. So in this case, your standard deviation, of course, will be a lot bigger. Are you guys good on that? So this is how you calculate standard deviation. Now, the mean rate, and I'm going to delete this. If you look at the handout itself, if you look at the handout, the mean rate, they gave you the units. They gave you the units. They say centimeter cube, s to the power -1, grams to the power of -1, which in some ways, if you kind of put it in fractional form, centimeter cube over s and g. Okay? Now, centimeter cube, that makes sense. That's pretty much the volume of gas that it collected. Over second, if you look at this column, they're saying volume of oxygen collected after 30 seconds. Okay? So what you would do here for this mean rate, you divide the average by 30 seconds. Now, that's not done. You're not done yet, because they say also divide S times G. S times G. So what's this gram means? This is the part when you look at the look into the question here. Down here, number 2C, calculate the mean rate of oxygen production. For the purpose of this exercise, assume the weight of germinating seed in every case was 10 grams. So what it means is that for each of these trials, you use about 10 grams of seeds. So in this case, well, this is where that grams unit comes in. So what you need to do, so for the calculate the mean rate, assuming that's the same thing, you use the average divided by, remember, it's 30 seconds. So divide, I put a bracket here, 30. And in computer language, star means multiplying times 10, because every column, every column, they use about 10 grams of seeds. Close the bracket, enter. Now it shows me the average rate for the day 1 for this set of data is this. Again, I drag it down and check, like, okay, so for column 2, yes, they use the date, the average of that column divided by 30 times 10. Same thing here, they use this average divided by 30 times 10, check, and check. Okay? So that's how you would do the mean rates for this one. Any questions? So for this exercise, that's how you would process the data here. As I said, you can use the table for that. In this here, you use the tabulated data to plot an appropriate graph of the results on the grid provided. So for this one, you can do it on paper. You can also do it on the computer too. Okay. And in terms of how do you do it on a spreadsheet, this is how I normally would do it. I would copy mean rate here. I'll just put it as a separate column here. Copy, what is this? Values only. Paste values. Oh, there's nothing to undo. Oh yeah, so it's here. So they copy the numbers, and I copy this here, days of germination again. Here. Okay, so what I just did, I copy this column here and this column here. Now I'm gonna do a graph on an Excel spreadsheet. When you do a graph, you highlight days of germination, and this 2 column take up all the cells. You go to insert, and you do charts. Now, when you do charts, yes. You should be looking at this and follow what this says. I'm just showing right now how to graph, okay? In this case, you will graph you should always plot scatter points. Always plot the scatter points. And right here, here's some fix up we need to do. So your X column, if you look, chart title, yes?
On the sheet, it doesn't say what to graph.
I know, so follow the questions. This will guide you, okay? If you want to ask later, if you want me to clarify that a little bit later on, you can. We can totally talk about that later. Okay. The error bar. So mean rates. Oh, actually. Insert charts, scatter. Okay, so you don't select the days of germination. You'll label that later on. You only select this cell. So 1, 2, 3, 4, 5. This corresponds to number of days of germination. This corresponds to the value that you graph. One other thing, for those of you who takes physics, and I'm not sure about chem, for us in biology, it's not uncommon that our line of best fit is a curved line. Yeah, it's not uncommon for biology. Our line of best fit is a curved line that looks like this or looks like this. You will see later on the reason why. So in this case, you will click on this here, and you will add trend line. Where do I do that? days have changed a little bit. So you go to series 1, and then you go trend line 1. You do that. Now here there is a trend line. But when you do a trend line, here they have different kinds of trend line. You can pick either linear, which is a straight line, or you can choose exponential, and they will kind of do it for you. And you will kind of visually have to look at it and see which one fits your data the best. Would it be exponential? Would it be logarithmic? That certainly won't work. Okay, is it polynomial? Now, if you see polynomial, I would just say right now for biology, grade 12, and even undergrad biology, first year, you won't use anything more than order of 2 or 3. Okay? 2 or 3, you don't use anything more than that. You will also, when you graph, you should also display the equation so you can see what kind of equation it is. What is the formula for the best line of best fit? Okay? So you can do the graph for this exercise on Excel, because on the lab that I will ask you guys to do on the later on the Thursday and Friday, I will want you to do the table and graph on Excel. Okay? So that's why I'm recording this right now. Any questions? Yes? This Thursday and Friday. So I'm just going to stop the video here.